In this video, I'm going to explain the many benefits of artichoke, and it has been studied for its effects on microbial biofilms, largely due to its polyphenols and flavonoids. So, artichoke has an anti-biofilm activity. Biofilms are structured communities embedded in a protective extracellular polymeric matrix, which I'll cover more in a different video. But artichoke extracts, particularly polyphenols, can disrupt biofilm formation and destabilize mature biofilms. And the observed effect is the reduced adhesion of bacteria to surfaces, which is a key early step in biofilm formation. Artichokes also interfere with the extracellular polymeric substance production as a result of that interference, weakening the biofilm structure. Artichokes also inhibit quorum sensing, which is a communication system that coordinates the biofilm growth and virulence. Now, some of the targeted microbes is Staphylococcus aureus, so a reduction in biofilm thickness. Also, Pseudomonas aeruginosa decreases EPS production and biofilm density. And some studies suggest that activity against Candida species biofilms by the fungi. So flavonoids and artichokes such as luteolin and apigenin are anti-inflammatory that indirectly reduce biofilm formation. Okay, another benefit of artichokes is that it is protective for the gut villi in the stomach, which are finger-like projections. They're basically a surface area for nutrient absorption. Factors that influence villus height, density, and integrity can impact digestion and overall gut health. And the effect of artichoke is that they are protective because artichokes contain bioactive compounds like luteolin and chlorogenic acid, which help protect intestinal mucosa from oxidative stress and inflammation. So in some animal studies, artichoke has been seen to improve the villus height and also enhanced villus to crypt ratio, suggesting improved absorptive capacity. So artichokes also contain inulin, which have been known to produce short-chain fatty acids, or SFAs in short, like butyrate, which nourish enterocytes and may promote villus integrity and regeneration. Also, artichokes they help tighten the gut junctions with the proteins occludin, claudins, ZO1, and E-cadherin. And these are essential for maintaining gut barrier integrity and preventing leaky gut. That's very important because a leaky gut means lipopolysaccharides, and the lipopolysaccharides are going to take up the space on the kilomicrons or the chylomicrons, however you want to pronounce it. And basically, if the lipopolysaccharides are taking up the space on the kilomicrons, the fat-soluble vitamins are not going to be shuttled and delivered to where they need to go because the lipopolysaccharides are taking up the space where the fat-soluble vitamins are supposed to be. So our artichokes help reduce lipopolysaccharides by improving the tight gut junctions, occludin and claudins, because if the tight gut junctions are tight because of those proteins, then the lipopolysaccharides will not be able to leak out and cause a fat-soluble vitamin deficiency. Also, artichokes help prevent the degradation of junction proteins, which is occludin and claudins, by preventing inflammatory cytokines that would have otherwise degraded those junction proteins. So, inulin fermentation from artichokes enhances butyrate production. Butyrate itself is also known to keep the tight junctions assembled and tight to keep the lipopolysaccharides out. Okay, now artichokes are also good for reducing LDL oxidation because artichokes have a strong antioxidants, chlorogenic acid, and cinerin. So some studies suggest that artichokes increase LDL receptor activity in hepatocytes, which means that this is going to promote the uptake and removal of circulating LDL, including oxidized LDL. Because if the LDL is oxidized, it's going to go into the arteries of the heart, and the macrophages are going to go in in an attempt to engulf the LDL, which is going to create foam cells. Now, foam cells as a byproduct are actually atherogenic, which means it's going to make even more inflammation if the foam cells are not cleared out in the heart. That's why artichokes can stop this from happening by reducing oxidized LDL. Artichokes are also known to block VEGF receptor 2, phosphorylation and downregulation of HIF-1A. These are hypoxia-inducible factors, also limiting new vessel formation in tumor-like environments. So basically, VEGF is a marker for angiogenesis. That means that cancer cells, they grow out blood vessels to proliferate. So luteolin and apigenin in artichoke can help reduce these blood vessels. Okay, another major benefit of artichokes is the apigenin in artichokes reduces C-flip. C-flip in cancer cells, like let's say in this study on a lung cancer cell. So what that means is with the C-flip reduced on cancer cells or tumor cells, it's basically that sensitizes the tumor cells to death receptor induced apoptosis, or FAD, or FADD in all caps, because the C-flip is reduced by apigenin, therefore allowing the apoptosis with FAD. And basically C-flip is a well-known inhibitor of apoptosis, because a C-flip competes with a caspase-8 for binding to FAD, and thereby prevents formation of the apoptosis. So apigenin from artichokes can lower C-flip, so that C-flip cannot compete with caspase-8. Therefore, the FAD can bind to the caspase-8 and promote apoptosis or programmed cell death. Another way, another thing that apigenin in artichokes helps with is it helps increase the FAS receptor expression that tumors try to hide, because tumors escape apoptosis by downregulating FAS or sequestering. So basically, because the tumor doesn't want to be visible to immune facile from cytotoxic T cells and NK cells. So the facile on the immune cells sees the FAS on the tumor cell that the tumor cell tries to hide, and then that the T cells and NK cells attack the tumor, but only if the FAS is not sequestered or hidden. So apigenin in artichokes brings out the FAS on the tumor cell. That way, the immune cell with the facile can see it and attack. Okay. Apigenin can also reduce aromatase. Aromatase is the enzyme that takes testosterone and turns it into estrogen. So apigenin in artichoke can actually inhibit aromatase, which reduces the conversion of testosterone into estrogen. Now, this is the whack-a-mole part of the video. This is where maybe you got to be careful with artichoke, because too much aromatase can actually, so too much apigenin could actually, if the apigenin is excessive, could actually be bad for your magnesium. The reason why is because if apigenin is too high, then it's going to inhibit aromatase too much, and then there's going to be too much testosterone, because there's not enough aromatase to reduce the testosterone as a result of high apigenin. What high testosterone is going to end up doing is that it's going to bring down your estrogen too much, and then that's going to lead to magnesium deficiency, because reduced estrogen means reduced magnesium transporter, so therefore leading to magnesium deficiency. If your magnesium is too low, you're going to have iron problems, because magnesium is needed for lysosome enzymes to work. Also, in lysosomal membrane peroxidation, magnesium is needed to repair the membrane of the lysosome. If the magnesium is not there to repair it, then there's going to be constant leakage of cathepsins and iron, and that's also going to lead to apoptosis, programmed cell death of your immune cells, leading to cancer to be free to metastasize because there are no T cells to fight the cancer. So leave your comments down below about your own insights. Like and subscribe, and I'll see you in the next video.